Hey guys, so today we're going to go over the study guide, but before I do that, I wanted to do a little bit of this, little bit of work with the correlation coefficient first. So I'm going to be jumping around a little bit. Let me present my screen so you can kind of follow along here. And I'm actually going to start by just reminding you what this correlation coefficient is. So you might remember this in the Ed puzzle. It tells how closely the data is to a perfectly straight trend line. Your R, which is the abbreviation for correlation coefficient, has to be in between -1 and 1. There is no R of 10 or -2.6 or anything like that. The closer it is to -1 and 1, the closer it is to a perfectly, all the data being on the trend line. So what I'm going to do right now is I'm going to go out to a site and we're just going to practice a little bit together with this idea of the correlation coefficient. So what I'm going to do is I'm just going to put some points on this coordinate system here. So I'm just going to, I'm going to make this be perfect, basically. I don't have to put them all in there. But if you're with me, say that was my data, what would the R be? What would the correlation coefficient be? Now, because these guys are all perfectly on that line, you're going to see that the R is a 1. It's a perfect correlation. They all fall on the trend line. That has nothing to do with the slope or the y-intercept. Okay, so let me clear that and let me do this. So if we kind of did this, okay, and then, what would this data represent? And you'll see, you'll still get the 1, but it has nothing to do with your slope or your y-intercept. It's the fact that all of the points perfectly lie on a positively sloped line, and that's where the 1 comes from. So let me just get a little bit more scattered. Easy to do these days. And I'm just going to kind of put some points in here. I don't know why that one didn't show up. Okay, and then I want you to guess right now, what do you think the R would be? And then I'll hit the show the line of best fit. And not only will the technology give me the R, it'll also give me the y equals mx plus b, the slope-intercept equation of that trend line, which you've been doing by hand. We will be using graphing calculators to kind of do that analysis ourselves pretty soon. Okay, do you have a good guess here? What is the R going to be? It's 0.98, very strong, but not that perfect one. Okay. All right, let me get a little more scattered. Now you can see that the points are still increasing. There is still a correlation here, but they're getting more and more scattered. Make your best guess here. What do you think the correlation coefficient would be here? And you see a 0.85. The more scattered the points, the harder it is for you to get that trend line in there more accurately. So the more the data scattered, when you do it by hand, the less likely you are to be, getting this answer if you did it by hand. Usually, let's flip our thinking a little bit here, and let's just get some going in the negative direction. Can you make a guess as to what the correlation coefficient would be of this data set? How'd you do? Okay, so you can kind of get a feeling, and now I'm going to go crazy and really scatter them. Okay. Okay, make a guess and see how it's, and like I said, it's harder and harder to get that trend line in. All right, let's go really scattered all over the place, scattered. What do you think? And you'll see it's very close to 0. I mean, this line is ridiculous, to be honest, that would even be a trend line. So the closer the correlation coefficient, this R, is to 0, the more scattered the points, and the closer it is to a perfectly straight line, the closer it is to 1 or -1, depending on, what the slope of the line is. Just so you know, we do not calculate this R. We use technology to give it to us. We can make a guess, we can estimate it, but we are not doing the statistical analysis. We let the technology do it. We do find our slope intercept, equation of a line, but we do not calculate the R. Okay, let's take a look. I'm going to go over now. We're going to go through the study guide, and this will be posted as well, but let's just see how you did on the study guide. So remember, as we're calculating slope, there are basically 4 types of slope. There is a positive slope, which number 2 was. There's a negative slope. There's a 0, which would be a horizontal line. And there's undefined, which would be a vertical line. You can see the vertical line by trying to divide by 0. That means that your x-coordinates are the same. And if your x-coordinates are the same, oh, by the way, the equation of this line would be x equals 3 of the line that goes through these points. It would be a vertical line. Let's just go over to the other special case, see the 2 y's. Oh, by the way, the equation would be y equals 6 of this horizontal line. And notice that the y's are the same, which puts a 0 in the numerator, which would be a 0 slope. So just kind of check your math now. On this one, you might have -5 over 1 if you went in the other direction. And on this one, you might have -5 over -12, again, if you started with the other point. The negative over negative, you should simplify to the positive, and it does not matter where the negative is there. So I'm hoping we're okay. The next thing we did was go on to rate of change, which is basically just the application of slope. It's slope with units, and we always find a unit rate when we're finding rate of change. Hardest thing is just to know who is your x and who is your y. So here we're talking about dollars and days. So we want to know what is the cost of dollars per day, which puts dollars in your y, and your time or the days in your x. So here are the 2 points, and I take y2 minus y1 over x2 minus x1. Don't leave it like this, divide it out. It will be $30.50 per day. Don't forget your 2 units. That's slope and rate of change. Okay, let's take a look now down at 6 and 7. The next thing we did was go on to the slope-intercept form of a line, which is y equals mx plus b. The easiest question is when they give you the y-intercept and the slope, you just smack them into y equals mx plus b. The number 1 mistake is to switch them. And then here, when it's not in that form, you need to solve transforming the formula. So you would have added 6 and divided everybody by 2. There now is your y equals mx plus b. So the slope is -3/2, and the y-intercept is 3. And just if this was a question, don't just list them. Make sure that you know which one is which. Okay, let's move on to some graphing. So it's really easy to graph if it's in y equals mx plus b. You graph the y-intercept and use the slope to move. I like to hook the negative to the top so that I go down 1 and run 3. So I fall 1 and run 3, line and arrows. Over here, -8. I'm going to go up 3 and over 1, up 3 and over 1, and put my line in. Now the reverse, you need to find your y-intercept, which is 4. And you need 2 points in the crosshairs, which I very clearly labeled, but that's where they came from. And I rose 1, 2, 3, 4, and I ran 2. And 4 divided by 2 would give me a slope of 2. Number 1 mistake here on this one is usually people forgetting to put the negative. So y equals negative, and notice I'm going down 1 and running 3. So down 1 and running 3 would be -1/3. Other mistake is to flip the rise and the run. And my y-intercept is -3. Okay, as we come, I think we're moving on now. Sorry. Okay, to number 13. Now we're talking about standard form. So this guy has 2 problems. He has fractions and the x terms on the wrong side. So the first thing I did was to multiply everybody by 6. 6y, 12 divided by 3 would be 4, and it's a -4x. And 6 divided by 2 is 3. And then add this guy around, and we have 4x plus 6y equals 3. Graph this guy. He is a vertical line through -5. And if you forget, just think that every point on the line has to have an x of -5. So -5, 1, -5, 5, and so forth. Okay, the next thing we're going to do is point slope form, number 15. Point slope is a great place to start, a horrible place to end. You take y minus the y coordinate equals slope times x minus the x. Distributive property, be careful with that second piece. And then I still have people I noticed on the quiz where they just add 4. You need to subtract 4. And if you cannot do that in your head properly, please write -4 on both sides. And in this case, it is going to be, what's this, standard form? Yeah. So actually what I'm doing is I cleared the fractions first. I just should have looked ahead here. So noticing I had to go to standard form, I multiplied by 2, by 2, by 2, by 2, and then it was easier to kind of join these guys up. So I subtracted the 8 and I added the x kind of in one step. All right, writing the equation, this is what I call a case 3 problem. So I had to calculate the slope first. Slope should be 6. Here is an example of how to get that. And then y minus the y equals slope times x minus the x, distributive property, subtract the 1, and there is my slope intercept. Alrighty, the next one, I'm apologizing for the big blob on there. I had a mess and tried to fix it with whiteout, and look what happened. It is actually really easy to graph this line without doing any work because it's in point slope form. So if you pull the point off, the point would be -4, 1, and you plot it, and then you can just use the slope to move. So if you have an equation in point slope form, you don't have to do any more work. Algebraically, you can just plot the point and use the slope to move. And like I said, sorry about that mess. All right, the next one, does this represent a linear function? This is just another version of sort of a type 3 problem in a way, in that we are looking at points and trying to decide kind of what the slope is here. So you got to find the slope 3 times. This one connected to this one, connected to this one, connected to this one. If the slope stays the same between all 4 points, which means you do have to calculate it 3 times, it's a yes. If not, it's a lightning bolt. So if the slope stays the same, they're linear from point to point, but you can't just do the outermost 2 and these 2 because you could have something weird happening in the middle. So you check the connections between every point. And in this case, -2/3, and it's a yes. If it represents a linear function, which it does, you're going to use your point slope, and you could have picked any point. I picked the bottom one. Y minus the y equals slope times x minus the x, did the distributive property, subtracted 2, and we all, no matter what point we use, should agree with this slope intercept form. Okay, here come the applications and the word problems. This is where, you know, a lot of people start to panic, but I hopefully over doing a lot of them, we start to know what to look for. So the first thing, we're emptying a 15-foot pool at 12 gallons per minute. The pool starts with 5,300 gallons of water. To be perfectly honest, there's a number in there we are never going to use. So the first thing I notice is that it's gallons per minute. It's leaving gallons per minute. That right there is your slope. The initial value, it started with 5,300 gallons. You're good. Y equals mx plus b. And don't forget to define your variables. And the 2 units here tell you what your x and y are going to be. Never use the fact that it was a 15-foot pool. Approximately how long will it take to empty the pool? That means we want 0 gallons. So 0 goes in for y. And this is a 2-step equation. So we would, I'm looking here, subtract, how did I do that? Oh, I just kind of got rid of the negative as well there. I added the 12x over and then divided by 12 to kind of avoid negative land. It's 442 minutes divided by 60 at 7.36-ish hours. Either one of those would be good. Okay, number 20, we're going to do a graph. So apples sell for $1.50 per pound and bananas for 70 cents per pound, and you spend a total of $10.50. So we got, this is kind of like that jogging and running problem we did a long time ago. So you got bananas and you've got apples adding up to a total. So this is a standard form. By the way, if you made this one bananas and that one apples so that your graph is turned around, there is no dependency here, and that would be okay. So if you have apples on the Y and bananas on the X, you're good. I went a little crazy here writing apples everywhere, and that's why I crossed it out and put bananas. Okay, so in my case, the X apples is going to get connected to the apple money, and the Y bananas is going to get connected to the Y. So the amount of money for the apples plus the amount of money for the bananas has to equal the total, basically. I'm going to do my X and Y intercept. So if I cover over the Y, that would be finding my X-intercept. That's like letting Y equal 0. And I take 1050 divided by 1.5 in my X-intercept. Right, is 7? Yeah, I'm sorry. I'm just taking a look there. And my Y-intercept 1050 divided by 0.7 is 15. I go to the X-axis, put 7. I go to the Y and put 15, connect them. And every point on this segment, because it would not have arrows, because it wouldn't make sense to go into the negative. So on this line segment, every point represents a combination of pounds of apples and pounds of bananas that would add to $10.50. So you can pick one, in the crosshairs. I think I have 2 here. You can use your 2 intercepts. So if you only bought apples, you would buy 7 pounds, and that would be $10.50. And if you only bought bananas, you could buy 15 pounds, and that would be $10.50. Or also 3 pounds of apples and 9 pounds of, again, bananas. I don't know why I was apple crazy. Will also give you the $10.50. That's a standard form. So we have done a case 1 and a standard form. Number 21, Avery decided to add $120 to a rainy day fund. After 4 months, she has $825, assuming no interest. So dollars each month, that is your slope. And this is not your Y-intercept. It's later on in time, so it's a point. So this is a case 2. I'm going to let X be the number of months and Y money in the fund in dollars. The money depends on the month. So the month would be your X and the money would be your Y. And now I go into the point slope and I get Y equals 120X plus 345. How much will she save after a year? That is why we put our units on our definition. We're not just going to slap a 1 in here because this needs months. We put in 12 and you should get $1,785. So I'm going to guess this last one is going to be our case 3 because I'm trying to give you one of each of the 4 types of word problems we've done with linear functions. So the last snowstorm started at 10 a.m. and the snow fell at a constant rate. Drew measured the snow at 11 a.m. It was 2.7 inches deep, and at 4 p.m. there was 5.5 inches of snow. Now the inches is going to depend on your time, and there's 2 ways to do it. You can kind of work with the times, but I chose to work with the fact that it was an hour after, and 4 from 10 a.m. would be 6 hours. And then I calculate my slope, 0.55 inches per hour. And then I put it into the point slope right here, calculate it, and I get Y equals 0.55x plus 2.2. How much snow was on the ground before the storm began? 2.2 inches. So basically, this is more like Jack living in Vermont. They've got snow on the ground, and then the next storm comes and adds to it. So right now, we would have a 0 before the next storm, but other places already have snow on the ground. Don't forget to define your variables. And in this case, X for me is the hours since 10 a.m., and Y would be your inches of snow. All right, we're almost there, peeps. Here comes parallel and perpendicular. So this one on the quiz, some people just kind of looked at it, not too many, but you cannot pull off the slope here. So you'd have to put it in slope intercept by adding 3x and dividing everybody by 6. And then you compare, and since they are negative reciprocals, it's perpendicular. Oops, sorry, I didn't realize I was off the screen. Let me leave that there so you can see it. All right, this was definitely the one we had the most discussion. So we want a line that's parallel to this guy. There's no X in here. He is a special case. Y equals 8 is a horizontal line. Horizontal. Parallel, another horizontal. If it's a perpendicular, we'd be talking vertical. But parallel, we're going to put a Y equals, and all you got to do is grab the y of the new point. So these two lines would be parallel. They're both horizontal, and this one would touch the point -2, 6. If this had been perpendicular, it would be x equals -2. And the x equals -2 and the y equals 8 would meet in a 90 degree, and the x equals -2 line would go through this point vertically. Okay, speaking of perpendicular, we want it perpendicular to this guy through this point in standard form. First thing we need to do is get the slope of the old line, which is 3/4. We had some people messing up signs, positive and negatives, on the quiz. Once you have the slope of the old line, you look for your P word, and it will not stay the same. It will reciprocate and negate, and now he goes away. You're going to take that slope and the point and put it in point slope form. You're going to do the distributive property. You're going to subtract 3, and notice I'm doing it as thirds, -9/3 to make it easy. And there is my slope intercept, but darn it, they want standard form. So I'm going to clear the fractions by multiplying by 3, and then add the 4x, and there is the final standard form equation. Okay, the last one here is to do the scatter plot. So did you put a title? Several people did not on the quiz of their graph. Your years should be here, and your minimum wage dollars per hour. I'm not going to use as I've told you before on many of the videos, I'm not going to put 1955. I'm going to put the years, and you know what? I really should be here, that I'm going to put the years after 1900. That should really be there. I go up, and I've decided to put a break in the X because I don't start till 55, so I don't want all this empty graph to the left. Whoops, sorry. So I put years after 1900 there. So I have a break in the X, and I'm going to start with, there's the, the 50, 60, 65, 70, 75. So I'm starting with 55 here, 55, 60, 65, 70, 75, 80, and so forth. Over here, I am starting at 0, and each block is 50 cents, and I've got to get up to, at least $8. I plot all my points. This is a really good one to get a trend line in there. I drew my trend line in, and then I find 2 points in the crosshairs, and I let Mrs. Woodruff know what they are. There are my 2 points. I calculate the slope, and my slope is about 0.12, and you should be close to that because this is a pretty tight correlation. Point slope, I picked this point, and I solve it, and here is my y equals mx plus b. And you should be really close to this based on how tight this is. You're going to use that equation to predict the number of wages in 2020, which would be 120 years after 1900. Sorry that this fell off. It comes out to $7.80 if you subtract those. And then you just finally had to guess, what do you think this is? I said about a 0.98, 0.99-ish. And we will learn how to do this process in the calculator after the test. And you can see that I'm kind of close. Oh, do you hear my cat screaming in the background? Oh my God, she's going to come in here. Come here, Emma. You want to meet everybody? Anyway, guys, I'm going to see if I can grab her. Stop presenting. It's really great and when she does it at like 3 in the morning. Emma, come here. Oh. She has stage fright. Anyway, that is the study guide. It is now up to you to be ready up through and not including 2060, obviously. Everybody should have turned their forms in to be able to borrow a TI-84 calculator because they're coming out to you real soon because we will do this scatter plot analysis in that calculator pretty soon. So study guide is good. We talked a little bit about correlation coefficient. Now it's really about practicing and being ready. I will have some practice for you during the Math 8 cohort time on Mondays and Tuesday for you to practice. There's IXL skills. I recommend going back and retrying problems. You're not going to probably remember the answer to the bridge gap problem or the shoe one. So, you can go back, whatever your trouble areas are, and retry problems, but don't do anything you don't have an answer to. Make sure that you can kind of check yourself. So I think that's it. I will see you guys soon on Tuesday, right? The test is going to have to be on paper. because there's no way to Google form this and have everybody do the level of work based on what kind of partial credit I have to give. So we will be doing that, but it will be flip-flopped. So this time, the end of the alphabet will be sending. So anyway, thanks for your patience, guys. I will see you soon. Have a great day. I'm going to stop recording and go find out what's wrong with the cat. And I will see you live in action.